What's going on, everybody? The networking guru here with Trepa Technologies, and today we're going to be going over domain 5.2 of our Network Plus free and full course. Like, subscribe, share it with your friends. Let's go ahead and jump right into it. So let me zoom my face out of here. Let's go over what we're going to do today. We're going over domain 5.2.2, troubleshoot common cabling and physical interfaces, and we're going over interface issues. So we went over some cabling issues. That's kind of more physical, right? What incorrect cabling can do, signal degradation on cables, things like that. But now we're going to get into an actual like switch or a switch interface, or even like a router interface will have similar issues sometimes, and go over the things that we got to look out for as network engineers and admins when it comes to the actual interface issues we can see and we might have to address, or we will address at some point in our careers. So the first thing we're going to talk about is a CRC error, or a cyclic redundancy check error. And before we jump right into CRC, let's take a look at our Ethernet frame one more time. So you can see this is our Ethernet frame. The first 8 bytes is something called a preamble. And just a side note, let's say I did a Wireshark capture on a interface. I won't necessarily see the preamble. I'm just going to see the actual MAC address headers. Anyways, so the preamble is going to be 8 bytes. That's going to say, hey, this is this is our preamble. And then 1 byte in there is going to be an SFD, our starting frame delimiter. I believe is what it's called, SFD. And then we have our destination source MAC address, right? And this is going to tell us, okay, where are we sending it? Who's it coming from? Then we have our Ethernet type. That type is going to say what kind of data we should be expecting. And then we actually have our data payload. And then behind that data payload, we have an FCS, a frame check sequence. Now that frame check sequence is going to be where we do our CRC checks. Are we getting cyclic redundancy check errors, which means are packets fragmenting? Is there data corruption? Is there something wrong? Does the receiving device need to recalculate the CRC compared to the original? If they don't match, it means the data was corrupted. So that's what our FCS, or our frame check sequencing field, is for, and that's where if we see CRC errors, that's because the FCS field is telling us, and it's going to increment, right? Another thing to note is the actual Ethernet size, the actual frame size. So at minimum, a frame needs to be 64 bytes at minimum. And then the maximum is going to be 1,518 or 1518 size. So you can see in the data payload, we have 1,500 bytes as the max of the data payload. And then the rest is just calculated, right, by our preamble, destination, type, and frame check sequence, okay? When it comes to those minimum and maximums. What you see on the screen here is a command called show interfaces on a Cisco switch, where it'll actually tell you if we have incrementing CRC errors. And if we do, that means we have some data corruption on that interface, and then we begin our troubleshooting process, which could start at layer 1. It could be in the configuration, could be we have half versus full duplex, something like that. Well, that'll have input errors, but a CRC error, right, is there's some data corruption. So CRC errors occur from various factors, including physical layer problems, hardware issues, or even compatibility issues between devices. And it's in the FCS field at the tail end of that Ethernet frame. So troubleshooting, we want to check for damaged cables or loose connections. Inspect connectors to ensure they are secure and not worn out. Maybe we need to check the transceiver types that we have, okay? Make sure we're not near some EMI, essentially, power lines, large appliances, things like that. So I know this may look a little blurry on the screen here. So what I want to do is I am going to show you an interface here on my Catalyst 9300 Cisco switch. And it still believes it's part of a stack, so that's why it's gig 6 instead of just gig 00. But anyways, so we can see here our CRC errors. We don't have any on here. So that means this interface has whatever's connected to it, and this is actually my error disabled port that we're going to go over in like a couple minutes. But you can see we don't have any, okay? But take note of what's right here, runts and giants. So a runt, right? A runt is going to be a frame that's less than 64 bytes. A giant is going to be a frame that's over 1,518 or 1,518 bytes, okay? Now we take a look at the maximum transmission unit, the MTU. Typically that's going to be set at 1,500. Now that's again for the data payload. When I say 1,518, we have to account for the entire frame though, okay? So that's when we start getting giants, when it's over 1,518. not necessarily this MTU size here, because that's telling us the maximum data payload or maximum transmission unit, okay? So let's go ahead and head back to our slides now. Okay, so runts. What are runts? Just described it. We're going to take a look at the slide here, go over some just more definition-based things. So runts are packets that are smaller than the minimum allowed Ethernet frame size, which is 64 bytes. They are usually considered invalid and discarded by the receiving device. So why do runts occur? Runts can result from collisions on the network, mismatched duplex setting, faulty network adapters and transceivers. Can also cause runt packets. The troubleshooting, obviously, show interface, right? Oh, we see runts are incrementing, right? When I say incrementing, it's because maybe we do a show interface and we see there's like 100 runts on there. I'm like, oh, there's an issue. So we start troubleshooting, we place a cable, and then maybe there was not an issue at all. You're just looking at an old, like the old runt counter that was from a year ago. So when you're troubleshooting these things, make sure you're doing show interfaces once, twice, 3 times within a 10, 20, 30-second period to actually see the incrementing, the increment. So it's actually going up. You can also clear the counters on there. You could clear counters on an actual interface. So it'd be like clear counters, interface, gig, whatever the port is, and that'll reset it. Do the show command again, and then you're like, oh yeah, that's incrementing, okay? So troubleshooting. Ensure that both ends of a link are configured with matching duplex settings, spec cabling, connectors, and things like that. You notice all the troubleshooting is very similar, and when we come to interface errors. Giants. So those are frames that exceed the maximum allowed size of 1,518 bytes for standard Ethernet. Kind of like the opposite of runts. Also, they're considered invalid. They get discarded. So from software bugs, hardware malfunctions, or deliberate attempts to overload the network, so it could be part of some sort of attack. Troubleshooting is going to be very similar. Obviously updates to if it's like a firmware, if it's a software bug, which isn't too common. Then verify network interface cards are properly configured, not malfunctioning. Things like that, okay? That's how we're going to troubleshoot a giant. Okay, drops. So what are drops? Drops occur when packets are discarded because the device is too busy or lacks sufficient resources to process them. This is something that we can actually utilize like quality of service if we have some sort of like bottlenecking. If we are just going past our queue, that's a dropped packet. So you may be saying, this is a crazy slide. A drop? Like, yeah, it's when data is dropped. I know, but in the Network Plus exam, this is on the actual exam objective. So we gotta hit it. We gotta talk about that definition. So drops are often caused by network congestion, overutilized ports, or insufficient buffer memory on devices. They can also result from device configuration errors, incorrect quality service settings, or just overloaded interfaces. If we come back to our secure CRT here, you see when we start getting like a lot of like errors, input errors, that may be like an overloaded port. We don't see that we don't see that as much anymore. Unless we have some sort of insider threat purposely trying to overload an interface. Just because we have gig, we have 2.5, 10 gig interfaces now, even on like a LAN. So you don't see that too much, but it can happen. Okay, back to our slides. Okay, now we're going to go into some port statuses. So what is an error disabled port? So an interface on a switch can go into an error disabled state when a link is flapping. So let's say a link is flapping up and down, maybe due to like a cable issue. Maybe there's another issue going on and it keeps flapping. So we're just going to put that in error disabled mode because maybe we don't want to generate those change topology notifications, mess up with spanning tree, things like that. Or there's a security violation. So there could be a spanning tree error. Maybe we put like some spanning tree, I forgot what it was, like BPDU guard on there. And then we get a BPDU, it's going to put us in error disabled. Maybe we have port security configured. So maybe as a network protection, some network access control, we tell that switch interface, hey, only have one MAC address ever assigned on this port. So when someone tries to unplug your computer, plug in their Raspberry Pi to infect us with malware, do some packet capturing with the promiscuous port, we shut it down. We're like, no, that's a second MAC address. We're only accepting this original MAC address that was just plugged into us. So we put our interface in error disabled. Now, when we troubleshoot, we have a couple show commands. So you see the command down here, show interface status error disabled. That'll show us all the error disabled ports. If it's from port security, we could have show port security command that shows us the violations on port security. If it's a spanning tree thing, we could have a command in there that automatically resets our BPDU guard and things like that. We could configure it. But the true way to get rid of an error disabled port is by flapping the link. So 1, fix the violation. So if it's a port security violation, clear port security, reset that link, right? And then flap it, okay? So let me show you that on actual hardware here. So I'm on my office switch. Let's go ahead and do some of those commands. It sucks that Cisco does not have the clear command. And let me bring my face into here in case I actually use this for like some social media. All right. So let's check our port security. So let's say we have a port security violation. So we see gig 06/0/10 has a port security violation. So if we do this command, show interface status, we're going to see error disabled. We're going to see, yes, that is error disabled. And we have that port security violation. So how do we fix this? So 1, to just straight up fix an error disabled port, we're going to come here to global config. We're going to go into that interface, gig 6/0/10. We're going to shut it. What I like to do is actually look at the interface. Let's see if there's like a MAC address sticky command on there. Okay, there isn't, but that's fine because we're going to clear it right now so that, new MAC address will come in. And we're going to no shut. And then once we do that, let's go ahead and take a look again. So show interface status, error disabled. Now we don't have any. If we do show port security, we still have that, like, hey, this previously has happened. But what we can do here is type in clear port security all. And then if we type in show port security, no more current address. So we do see there was a security violation on there before, but now we have cleared it. And now we're good to go. Now we don't have an error disabled port. Awesome. Now let's get back to our slides. Administratively down. So something that could happen in our environments is just a port's down. User plugs into the wall. Hey, the internet's down. That's the ticket we always get. The internet's down. So simple. Hey, user, tell me what's written on there. What's written on your wall jack. Tell me that so I can go on my diagrams, look at what comms closet you're in, where you're patched into. I'll SSH to that switch, and let me check to see if you're actually down. So again, another way to see if a port's administratively down, I'm going to come back here, is we can type in show interface status. Not connect means that it's up, but nothing's connected to it. Disabled means that it is administratively down. We have this command called show IP interface brief. I'm going to type in only include gig 06 because it's just that's okay. We can just, it's gigabit ethernet. You know what? We don't need to do all these exclusions and pipe commands. It's okay. So you can see here, this is also a way that we can look to see if a port's administratively down or just down, meaning something's not connected to it. I'm going to do my pipe command again. Gigabit Ethernet 6. Okay, so you see these ones are up right here. That means something's connected to it. You see these ones here are administratively down, all right? They're administratively down, which means they're shut. So if I come in here to global config, type in interface range, gig 6/0/0 through 10. Where are we at? Sorry, 1 through 10. We type in no shut, and then do that command again. Do show IP interface brief pipe include gigabit Ethernet 6. Now we can see that instead of them being administratively down, they are just down. Difference, okay? Administratively means we went in and actually said, hey, turn that port off. Come back to our slides here. Suspended. So there's another thing. It's very similar to error disabled. Not quite, right? Because, it's not port security. It doesn't suspend a port, puts it in error disabled. But suspended port, that's a state where it cannot forward traffic due to policy violations or misconfigurations. Typically, we see this in misconfigurations. So a common example is, let's say we configured Ether channel with LACP on one side and the other side either isn't configured or misconfigured. We'll notice that the member interfaces, which are the physical interfaces that are a part of that port channel, will be in a suspended state. So let's show you that here as well. So if I come here to switch 2, this is again Cisco switches, okay? Looks like I'm frozen here. I may need to restart this connection. Let's see if I'm good on switch 1. I am, but switch 2 is what I configured. I'm going to pause the video. We'll be right back. Okay, we're back. Switch 2. If I come in here to switch 2 and type in show ether channel summary, we can see that we have gig 00 and gig 01 are in a suspended state. So essentially that means switch 1 is not configured for LACP. So if I come over here to switch 1 and I type in interface range gig 0/0 through 1, channel group 10, mode active. So I'm going to put them in also LACP. After a few minutes, our port channel should come up, and if we come back to switch 2, we're going to see they're no longer in that suspended state. So because it was misconfigured before, our interfaces were in that suspended state. But now, we're good to go. All right, so now let's go ahead and do our quiz, guys. So we're at our learning management system here, our academy is what I like to call it, because it's our Trepa Tech Academy. If you want access to this too, click the link in the description below. You can pay for this course, our full Network Plus course. You can, if you're in the Army, have it paid for. But let's go ahead and go to our Network Plus course. Let's go to our lessons here. We're in week 4, domain 5.2.2. Let's scroll down and take that domain quiz. Let's zoom in here so we can have a good view of it so we're not squinting our eyes. Bring my face down here. And let's go ahead and jump right into it. So question 1. What is the term for Ethernet frames that exceed the maximum allowable size of 1,518 bytes? That is going to be a giant. Awesome. Let's see the explanation. Pause if you'd like to read this. In our Academy site, all these quizzes are the same. Explanation, discussion, comments. Question 2. Which of the following steps should a network administrator take first when troubleshooting an interface with frequent dropped packets? So we got packets just dropping here. What should we check first? Okay, so obviously this is a loaded question. I think what it's trying to say is, hey, CompTIA wants you to know the term drop. Packet drops. And so when it comes to packet drops, the definition for the Network Plus exam is there's maybe congestion, something wrong with the actual link. Think more like logical now. Now, obviously, if we're talking to a user and they say the internet's out, you want to troubleshoot layer 1 to 7. But this is more like we're monitoring that interface. We're noticing full packet drops instead of just CRC errors, things like that. So we're going to be D. Obviously, when we talk about CRC errors, that would more likely be B. But don't get caught up because we dropped packets. That keyword drop, okay? So let's go with D here. You can pause the video and read the explanation. Question 3. A technician observes runts in the network interface counters. Which of the following is the most likely reason for these runts? So I'm going to go with A. Collisions caused by mismatched duplex settings. Go ahead and pause the video if you'd like to read the explanation. Question 4. A network administrator notices an increase in CRC errors on a switch interface. Which of the following is the most likely cause? So again, okay, CRC error. So now, different than dropped packets, so we're going to go with B, physical cabling issues. So yes, we're going to go with B for CRC errors. Maybe there's some interference, physical cable, we're using unshielded twisted pair, just things are messed up, right? Go ahead and pause the video if you'd like to read the explanation. Question 5. A port on a switch is showing a status of error disabled. Which of the following could be the cause? Error disabled. I'm going to go with C. Security violation or excessive link flapping. And that is error disabled. If we want to clear error disabled, what do? Shut, no shut, you flap that link, okay? Pause the video if you'd like to read the explanation. Question 6. A network administrator notices that a port has an administratively down status. Which of the following actions should they take if the port needs to be active? Guys, I mean, turn that port on. That's going to be C. Use the no shutdown command on the port. Pause the video if you'd like to read the explanation. And boom, look at our results. We got 100%. So I want to thank everyone for viewing. Like, subscribe, hit that bell, share it with your friends. And if you want access to our full course, our live virtual training, hit the link in the description below. I'll see you in the next video.